Hello everyone. This is one more interesting video that is related with the stereographic projection, and this question came in 2025 IIT JAMS exam. So similar type of questions has already come in GATE as well as in CSI and NET exam. Okay. So this topic is very interesting, and in future exams we will also get this type of question again and again. Okay. So our concept is very important in this case, okay? And some few things we have to remember or tricks you can say. On the basis of using that we can easily answer these questions, okay? And apart from this, if you have any question related with StereoNet or anything that you want to discuss with me or need to understand from me, I'm ready to help you people and ask question from the system from wherever you are learning, okay? Then your craze towards early is created na? And okay, share this video with your friends and discuss among each other. Okay, I will try to solve this question as simple as I can. Okay, but we need some basic information for this, and already some of the videos I have already related with stereographic projection I have already made and upload. Okay, in playlist you can go and check out those videos. Okay, for better understanding. Okay, uh, I will try to add more information in this question. Okay, apart from this question I will add more information. Okay, so that in future if we will get some similar type of question you are able to answer. Okay. Okay, let's start our question. Opportunity will come and go, okay? Don't wait for the opportunity, okay? Now let's solve this question. In this question, what they are asking, which of the following stereographic projections represent an upright plunging fold? I have drawn two lines, okay? For upright as well as a plunging fold, okay? So now, what is upright fold, okay? Upright fold is when axial plane means symbol is AP, okay, given in this, okay. We will read this, okay, and hinge line is given, his symbol is HL, okay. Upright fold is when axial plane is vertical, okay. Axial plane is vertical like this, when something is like this, okay. So this plane is vertical, and plunging fold is plunging fold is when hinge line, our fold axis, okay, is inclined, not vertical, okay. First we will understand this, okay, how. Now we have to, in our question they are adding both the terms in one upright plunging fold they are asking now. Now upright plunging fold is when hinge line or fold axis is not horizontal. This is our, suppose this is our fold, okay, this is our fold and this is our maximum curvature, okay, and this is our, if we will join our maximum curvature we'll get a hinge line, okay. In this case hinge line is our horizontal, so this is our non plunging case, non plunging case, Okay, but if our hinge line is like this, okay, our hinge line is maximum curvature area, okay, hinge line is X. Now it is making some angle with horizontal. This is our horizontal plane. It is making some angle with this. Now we call this angle as a plunging. Okay, our hinge line or fold axis is plunging in this case. Okay. Next thing is, now we have to add these two. Okay. Upright fold means, suppose this is our fold and this is our axial plane. When axial plane is vertical, we call it as a upright fold. Now we will club this one and this two. Okay, now we will get what similar type of picture like this, but in this I have not drawn that axial plane. Okay, I will conquest up one more time. Okay, in this way. Okay, this is our hinge line and fold axis. Okay, and it is having some angle. Okay, it is having our some angle. We call it as a plunging. Okay, so now I will draw the axial plane. Axial plane is the plane which divide the fold into two equal halves. The curved part. Okay, but it can be like this, inclined also. Okay, horizontal also. Okay, this axial plane can be inclined, horizontal, vertical, and okay, but in upright fold, for upright fold it should be vertical only. It should be vertical only. It is a mirror image. Okay, that cut the fold into two equal halves. Okay, this is our diagram for this upright plunging fold. So now in upright plunging, now how we will represent this in stereo net? The question is that now, how we will represent this in stereo net? Okay, so to put this thing in stereo net, we need little basic for that. Okay, first, suppose this is our stereo net. For more detail, you go to playlist and watch from there. Okay, I have already uploaded the basic of stereo net. Okay, and some exercise already there. Okay, suppose this is our stereo net. Okay, and in that north is mark over here. Okay, now we have to plot our data. Okay, this data into this. This is our grade circle. We call this as a grade circle. Okay, and it is like there are two type of curve. Okay, there are two type of curve on it. Okay, I will change the color. Okay, one curve is from like this. One curve is like this, and one curve is like this. How we will use these curves? Okay, one is in north south direction, other one are like our latitude longitude on earth. No? It is like that only. Okay, but don't compare in that way. Okay, Our earth is a sphere now. Don't consider it is a sphere, but we are cutting in a plane. Over that we are understanding, okay, the things. These red lines are we are calling as a smart circle, okay. So now to plot this data, okay, in field we are observing this and we have noted our data, okay. What we are observing that our data is like our actual plane is vertical, but trending north 30-degree east. With respect to this, I'm writing, okay, this is our north, this is our east, this is our 45-degree, but it is less than 40. I'm supposing as a 30-degree, okay. It is a 30 with respect to that I am writing, okay. So our data is like this. So north 30-degree east. So north 30-degree east will come at this place. North 30-degree will come at, suppose this is our north 30 will come at this place, okay. And we have to, okay, after marking this point we will rotate over this thing to north, okay. And after rotating this to north, okay, so now we will calculate our data from dip from this side. In our case it is dipping vertical, so at circle it is 0, at circle it is 0, at center it is 90-degree, okay. This is our 90-degree, so it will passes from center. It is 90-degree now, so it should be passed from center. Here it is 0, in center it is 90-degree, okay. So after, now we will join that line, okay, from this point to this center, okay. And after rotating to its original position, okay, so we will get a line like this. This amount we have measured in east west, okay, from this end or from this end, from both end we can measure, okay. As our case it is 90 degrees, so it will come at center, okay. If it is given like this, east actually is dipping toward east 30-degree, from east we will calculate, okay, 1 2 3 like this, okay, up to 9, and after 9 division is there, okay. So wherever it is come, so we will draw a curve on that one, okay. Okay, so now our point is in center, so straight line will come, okay. Now our point is in center, so straight line will come, okay. Now this straight line is again rotated to this point, okay, so we will get this line, okay. Now we are getting our actual plane, okay, data. Now some angle is there, we have to plot this data also, okay. Suppose it is 20-degree or 25-degree. How we will plot this data? For plotting this data, okay, plunge, we will use this north south line, okay. We'll use this north south line. Again we will rotate our line to this north and calculate from this circle, okay. Now we will in that actual plane tip we will calculate from east to center, okay. Now we will use from our poles, okay, north or south pole, okay. From north we will calculate, okay. This line 1 represent 10, and it means there small lines are there, okay. So 10 20 or somewhere we will get. Now our line is rotated to this place now, so our point will come here, okay. This point is for, okay, this line represent what, this line represent actual plane, and this point represent our hinge line or fold axis, or lineation also we will measure in a similar way. Okay, so now we will go back to our options. Okay, first thing is that for upright plunging fold we'll need a vertical axial plane. Okay, that is making 90 degree, and if we plot that 90 degree in our stereo net, it will passes from, the line will should be passes from our center. So in which case the line is passes from center? In this case, and this case line is passes from our center. This is for upright fold. Okay, now for plunging fold, line should not be at 0 degree. Line should not be at 0 degree. That point, hinge line point, should not be at circle, because at circle it is 0. At 0 we call it as a non-plunging. In this case it's non-plunging, it should have some plunging. So our point should be within so within the circle. Okay, within this circle. Okay, in all the cases, our point is within the circle. Point is within the circle means all are non-plunging. All folds are all folds are plunging. This one is plunging, this one is also plunging. Okay, all are plunging. Okay, but we need to what? Upright also. For upright, our axial plane line should passes from the center. So these two are the right options. Okay, like our P and R are the right options. Now our question is solved, but we will add some more information. What this represent now? Okay, these two are upright plunging fold. Okay, this is inclined fold. This is what? Oh, sorry, plunging fold. Okay, upright plunging fold. But this is vertical fold actually. This is our vertical fold. Why I tell it that this is a vertical fold and this is only a upright plunging fold? Although this is also upright plunging fold, but its name is vertical fold. Okay, so for vertical fold, look at this carefully. Okay, okay, now if I will construct one axial plane, our axial plane is 90 degree with the horizontal plane. Axial plane is 90 degree with the horizontal plane. Now our line will pass from center, and it is in, suppose this is our north, so it is in north west direction. So line will passes from center. Now our hinge line is the point where maximum curvature. This is the point where maximum curvature, and similar way here it is. So this is the line. It is also making vertical. It is also making 90 degree. So we will calculate from where? Hinge. We will calculate from this point now. From this point, center here it is 0 and 90 will come at center. So that's why I call, so this is our vertical fold as well as upright plunging fold. Plunge is also there. Our plunge is also there. That is 90 degree. In this case, plunger hinge line is dipping 90 degree. Okay, and our axial plane is in north west direction. Okay, and in this case our axial plane is north east or north northeast. Okay, and it is plunging in which direction? Here it is difficult to tell that. in this vertical fold, it is difficult to tell that in which direction this hinge is dipping, okay, because it is a vertical fold now. So in this we are not able to tell, but in this case we are telling, okay. How we will tell that in which direction it is dipping? We'll just rotate this point to north, means align this point with the north line, okay, with this line, okay, and draw, means if it is on the same plane, means vertical plane, so its direction is also the same, but not in this case. In this case, I will explain that also, okay. Okay, now two options are clear and our answer is also we are getting, okay, but now we will understand these two also, and apart from that some other stereonet for fold also, okay. So if we look at this case, okay, so in this case our axial plane is curved, oh, means axial plane is inclined, our axial plane is inclined, okay, it is not vertical or horizontal, okay. If it is horizontal I will tell later, okay. Now it is inclined and our hinge line is the same case, this case our hinge line is the same case. So now how to imagine this, okay, how to imagine this, like this is vertical now. So now how I will make this is, actually it is seems like it is in the center, okay, but it is not center, okay. Center will come somewhere here, okay, center will come somewhere here. Actually it is a reclined fold, it is a reclined fold. What is reclined fold? When hinge line and axial plane both are dipping in same direction, both are dipping in same direction, okay, and that hinge line or fold axis is less than 90 degree, or it may be 90 degree, okay, near to 90 degree, okay, but not 90, okay, exactly, okay, it is less than 90, okay. 80 means 80 to 85, it means 80 to 90 means 88 or something like that, okay. If it is like that, we'll, and axial plane is inclined in that case, okay. How we will make this diagram, okay, we have to understand this diagram in our mind, okay. How we will understand that? This is a vertical fold, okay. I have to incline this fold, means this axial plane, this is our axial plane, this that I have constructed like this. Here it is vertical, I have to incline it. So for incline it, either I have to tilt it in this way or either in this way for axial plane, okay. Anyway you can tilt, okay, either this side or this side, okay. Now this is one thing, okay. Now our axial plane is getting either this way little or this way or this way, okay. So now our fold is like this. This is our getting clumsy. Wait. First we will make picture also, okay. Okay. Now our axial plane is getting inclined, okay. I have tilted a little bit it toward this side, okay. And our hinge line is still, and hinge line is dipping toward the same direction, okay, where our axial plane is dipping, okay. This is for hinge line also, no, it is also dipping with the, you can try with your hand, okay. You just make it vertical fold and then just tilt toward right or left little bit, okay, and then tilt toward this hinge line, tilting this hinge line also, this is straight now, means in that the same direction we will little bit tilt this also, okay. So in that way for tilting the hinge line, okay, either we will tilt our hand in this way or in this way. So we have to do both the things, okay. For getting recline fold, we have to tilt our axial plane as well as our hinge line also, little bit, okay, from 90. So we get our perfect recline fold, okay, in that case, okay. If you are unable to visualize, because it is difficult to make recline fold, okay, here, okay, I will prepare 3D model if you need that, okay, separately, okay. In that I will explain that one, okay. So now this is our recline fold. So what is this fold? And here axial plane is inclined, okay. In this case axial plane is inclined. This for recline fold. And what is this fold? This we can say that inclined plunging fold, okay. Inclined plunging fold, okay. This is also inclined plunging fold, okay, but it has a name, okay, due to this both the things are dipping in same direction, okay. Decline fold, and the angle is between 80 to 88 or something like that, okay. You can call it as a decline fold. Now apart from this I have some other types of, if it is all are plunging, in this case all are plunging now, so now I will take some cases of non-plunging also, okay. First one is vertical non-plunging. In our question it is vertical non-plunging. Vertical upright, you can say, use upright also, but non-plunging, okay. So our stereonet will be like this. If it is non-plunging, okay, so our hinge line, hinge line or that fold axis or lineage, that lines or fold axis will come on this great circle, okay, whichever whatever is the direction, okay. But it is upright, it will pass from center like this. So our that hinge line and this point will come on here or this side also, in any side, okay. This is the case, okay. This side also, okay, no problem, okay. Whichever is the given data, okay. So this data is north, east, uh, with dipping, means this hinge line is also dipping in, means hinge line is also, hinge line direction is in also the same direction of that axial plane, okay. And there is no angle, okay. For hinge line or fold axis, zero angle, okay. That's why it is non-plunging, okay. Next one is recumbent fold, and I will construct this fold also, okay. It is simple fold like this. Here axial plane is vertical and this is our hinge line. We will construct this way, okay. Now if it is horizontal, it means recumbent fold. Recumbent fold. In recumbent fold, our limbs and axial plane is getting horizontal. So in stereonet, how we will plot? Both are horizontal, so both have 0 degree angle. So our great circle will represent both the things. This great circle itself represent a axial plane. This great circle represent a axial plane, and this great circle itself represent that one also, our hinge line or a fold axis. If our fold is inclined but non-plunging, fold is inclined. For inclined fold, our axial plane will be like this, inclined, simple, and it is horizontal. Non-plunging, na? So how we will draw? We will draw a circle, okay, and this side it is dipping, we will make our curve in that direction. Suppose it is dipping in this way, calculating from east west direction how much it is, and for that hinge line we will either put point on this side or this side, whatever it is the data. One is, apart from this there is one more, overturn fold. Overturn fold is like this, okay. Suppose it is now eroded, we are getting up to this only, okay. So this is our actual plane. So now we are measuring both the data, actual plane data, limb data, and this limb data also. Both we will measure, okay. So how we will plot this data in our stereo net? Both are dipping in this direction, and it is not 90 na. So our data is how much we are plotting. This, suppose this is 20 degree, 30 degree suppose. This is 40 degree or something, okay. Suppose making little higher angle, okay. And this is our 60 degree, 80 degree or 70 degree, 70 degree suppose, okay. So from here we will start 30. Here we will get 90 na, in center. From here we will get 30 here. We will draw curve from north south direction. Okay, this is limb 1, suppose. This is L2. For L2 I will change the color, okay. Black I will use. For L2 it is 70 degree. 70 will come near to 90. So this is our second limb. This is our L2 limb. This one is our L1 limb. Now our actual plane will come in between this 40. Is our actual plane, suppose. So I will draw actual plane like this. Okay. So from these two curve, okay, the one is near to our great circle having less angle, and one is near to our center having more angle, okay. That is pole, okay. So in this way we can, and both the things, okay. From here to here they can ask, from, they will give this picture and they will ask us what kind of fold it is. So you have to understand this way, okay. The outer one having less angle and inner one having more angle, and both are in same direction toward west, okay, toward west. So we can say that this is a overturn fold. Overturn fold, okay. I have already added too many things in this simple one question. If you have any, if still, because these things are not that easy, I know that, okay. It will take time to understand, okay. So if you still have doubt, any query in between, you can ask me, okay. I will give my best to you, okay. And hope you will crack your all the exams, okay. Ask question from the system, share this video with your friends so that they can also get benefits and discuss among each other, okay. Thank you, hope you learned something from this video.